Okay, I guess that's that. So, let's head off to a start in our research and investigation, and quite a difficult topic for purpose of today's webinar, which we selected is preparing your infrastructure for remote access. Now, the result of the recent COVID pandemic is unfortunately, for the time being, uh, overcome and with the maximum effort. Its influence has taken a large toll on the way we work, live, and communicate. And since our daily social interactions are now divided by a distance between offices, colleagues, clients, and your production environment, bridging the gap is the only way out. Now, during the past several weeks, daily workflow has demonstrated peaks of requests with the highest priority, which came bundled with immediate client on-site just to meet a business critical demand. Now, even if the infrastructure performance, resiliency, and backups were optimized, improved, and scheduled, no one was ready for the massive demand and remote infrastructure access that turned out to be vital. Now, in the past, the most important aspects of production environment were its resiliency and data redundancy. Now, the most important aspects that should never be taken for granted is also the security. Now, due to the current conditions, the system administrator is faced with a large amount of tasks, which never left any time for any research or any possibilities of implementing a solution which was required. Now, all the simultaneous requests leave no time for research, especially at the moment when making a trade-off between providing client access or provisioning the right amount of compute storage GPU was crucial. Now, given the responsibility involved in the modernization of your existing infrastructure, accommodating the multiple requirements of deploying a simply accessible, secure, and cross-platform solution turns into an infinite search. Now, the process of finding the right feature set to deploy a one-size-fits-all remote access solution turns into a never-ending project. And since the deadlines have long surpassed its planned deployment in production, the improvement of user experience is as important as ever. And just to make sure that those deadlines are always met, I'd like to share a blueprint for the deployment of a remote desktop solution within your existing or future Microsoft environment. So why don't we leverage the current conditions toward the improvement of your infrastructure? Great idea. Now, having the need to implement solutions that would allow the user to achieve their mission critical tasks involves the lack of standardized access, provision access rights, and the assignment of associated PGO policies, which lead to an entangled mess. The options for on-demand support access to the user's device are endless. I'm quite sure most of the viewers have used several, if not all of them in the past, and many still may do, but some of the most important methods would include GoToAssist, TeamViewer, Splashtop, ConnectWise, VNC, Radmin, and even Skype screen shares. Now, since they all differ in security, quality, cost, and convenience, some of the solutions add complexity by having a requirement of installing additional components for achieving as simple as it may seem of a task, unified remote user access. Now, the requirement for remote access is unique in every case, be it for the purpose of assisting the user with gaining access to their work environment, database, data, or the compute of the production environment. But nonetheless, it always has to be secure. Now, for that particular purpose, we knew that it would be great to share a Windows VPN credentials with your users, and glad you've done so in the past, but can you be sure that the previous configuration was the most secure? Let's find out. Now, since there are various Windows VPN tunneling protocols available, it's a matter of picking the right one for the job. Now, let's start with PPTP, which is a very old technology that has been proven quite vulnerable. However, it's incredibly easy to set up, and it's present on all popular operating systems. Now, next one will be L2TP, which has been the most secure protocol for quite some time now. However, security vulnerabilities have discovered during the past few years, which poses a question of whether you should still use it, but it's easy to set up and it's efficient. Definitely a better option than PPTP. Now, another one would be OpenVPN, which is one of the most popular VPN protocols, and it can be used across different types of devices. And amongst all hugely popular VPNs rely on this protocol. And in short, this could be your go-to choice. Now, the last one would be IKEV2, or also known as IPsec, which is one of the newest VPN protocol standards, and never really reached its full potential. It allows for secure connections and high performance, but it still doesn't present all the currently popular operating systems. Now, given the differences between the available VPN options, the best solution for our use case would be tunneling to a Windows Server 2019 without TTP over an encrypted IPsec VPN. Now, the main reason for that is due to its very strong encryption of data exchanged between the remote server and client machines. But nonetheless, either one can be used for the configuration of the VPN connection or any type of help desk troubleshooting. So once configured, you might be asking yourself, how would I monitor all the active VPN connections? Quite simple. The process of monitoring the status of the VPN services can be done via the Remote Access Management console. Now, the interface will provide you with the number of active clients, VPN connections, and data throughput. Putting our aspect of security in check, just wanted to change the subject now. In older versions of Windows Server, session-based desktops were provided by a feature named Terminal Service. Now, terminal services had the same basic functionality for session-based desktops as RDS, but RDS has been extended with the additional functionality to improve the user experience and manageability. Now, one of the most common uses of RDS is the deployment of a session-based virtual desktop. In a session-based virtual desktop, all processing is performed on a remote desktop session host, and the results are displayed on a remote desktop client. So this now leads us to the best and most popular method of remote desktop access, the Windows RDP. Now, RDP is a very efficient protocol and sends a limited amount of data over the network, and this makes it possible to use RDS to provide desktops with users over LAN, from branch locations, over WAN, or over the internet. Now, as most of you already know, it's a cross-platform and is able of tailoring for any kinds of internet throughput and scale to match the size of even the bigger user displays. Great, so with all that taken into account, let's look into the types of access to Windows Remote Desktop Services. Now, for starters, just so you know, RDS can be deployed in three different ways. A session-based deployment, which is a traditional way of delivering virtual desktops to users and would require a large amount of usable storage. Even though there's only a single copy of the operating system installed, a session-based desktop deployment can achieve a greater amount of density of concurrent users per server than virtual machine-based desktop deployments. Second would be pooled VM deployment, which would deliver a full VM per user, which can be either pooled or personal. Now, the pooled deployment would include functionality of unified management, extended remote FX capabilities for 3D rendering, for example, data storage flexibility, allowing storage to be used for client hard drives that can be deduplicated, the dynamic memory allocation that would allow to dynamically allocate your RAM to any particular VM, and the possibility of deploying it in a high availability scenario where each role involved can be made highly available by placing it on the replicated cluster storage volume. Now, the third type would be personal VMs. Now, the personal VMs would provide you with flexibilities of session shadowing, where it would be possible for you to monitor or access a session either with or without the user being aware. Online data duplication can once again be enabled for your client VM drive, delivering phenomenal storage savings. Quick Connect for remote desktop clients is also something that's available and can be improved, allowing for much faster reconnects to sessions which have been disconnected. And improved compression and bandwidth usage with up to 50% less due to dynamic protocol switching for different contact. And dynamic display handling would allow better support for monitoring touch devices and screen rotations. Now, this would actually be the moment when you would need to make a choice between sharing infrastructure resources across multiple sessions or dedicating separate resources to each user and making a decision in between going into the direction of RDS or VDI, which would in result lead us to the next slide. Now, the VDI, Virtual Desktop Infrastructure, is a term used to describe users accessing a full desktop operating system environment remotely. Now, a desktop could be a normal PC or a virtual machine. Now, since the typical VDI deployment is based on RDS, which is built around Windows Server operating system, its architecture would involve the following roles. The remote desktop connection broker, which would allow the users to reconnect to their existing virtual desktop, remote app programs, and session-based desktops. And in very simple deployments, the connection broker would not be required. The remote desktop gateway, which enables authorized users to connect to virtual desktops, uh, remote apps, programs, and session-based desktops over a private network or internet. And basically, it would enable the secure access from a public network into a private network. Remote desktop web access would enable users to access remote apps and desktop connection through a start menu or through a web browser. And remote app and desktop connection provides users with a customized view of remote app programs, session-based desktop, and virtual desktops. And the last would be the remote desktop licensing, which quite obviously would enable a server to manage RDS client access licensing that are required for each device or user to connect to a remote desktop session host server, which we'll look into just a bit. Now, a VDI deployment, there actually has two models, a static or persistent virtual desktop and a dynamic or not persistent one. In static mode, there is one-to-one mapping of VMs to users, where a dynamic architecture, or on the other hand, there's only one mastering image of the desktop stored. Now, a virtual machine deployed on a Hyper-V host would allow you to pre-configure a standard gold image for remote users, and if you already have a corporate WIM, then you can convert the image into a VHDX or even build a VHDX file with a config management tag sequence to serve unified and consistent remote user sessions and replace it when any updates need to be made. But nonetheless, additional benefits of deploying a remote desktop virtualization host would include no impact on other users residing on the same infrastructure. Resources can be added to the desktop when needed. The consolidated management would provide you with additional flexibility as to managing all the remote desktop interfaces and optimize media streaming, allowing new codecs to solve bandwidth problems, and followed by a DirectX 11 support with discrete device assignment. In addition to the available DirectX 11 compatible hardware, software emulation can also be used, even mixed for both sessions, virtualization and virtualized machines. And due to the nature of the discrete device assignment, when implemented, some features of the virtual machine would be restricted. Now, some of the features would include saving or restoring the VM, the live migration of that VM in between the hosts, the use of dynamic memory, or adding the VM to a high availability cluster. But on the other hand, of the limitations are not something you are looking forward to, the remote desktop service solution would be just right for you, which is formally known as a terminal service. Now, remote desktop services provides multiple users access to share the same operating system and applications running in the server. Now, just like VDI, RDS itself is also a combination of the previously mentioned roles, but with a main difference: a remote desktop session host instead of a remote desktop virtualization host. Now, the remote desktop session host enables a server to host both remote app programs as well as session-based desktops. Users could connect to the remote desktop session host servers and a session collection to run programs, save files, and use resources on other servers. Users can also access remote desktop sessions host server by using the remote desktop connection client or using remote app programs. Now, while RDS can also be used in enterprise environments, it is more appropriate for smaller organizations with higher sensitivity to costs of IT. Now, typically, a 15 to 30 users which are put on one server, RDS would allow the infrastructure to be utilized to the full potential, much more than in the case of a VDI. It brings another level of consolidation and price reduction. Nonetheless, if you have one or two very demanding users, maybe more, of RDS, they can utilize whatever resources, be it CPU or memory, which are available and therefore impact other users' experience, which are residing on the same server. If this turns out to be a problem in the long run, more demanding users should be moved to a dedicated VDI-like server. So at the moment, the remote desktop session host can be considered more cost efficient than VDI, but this situation may be changing in the light of Microsoft's partnership with Citrix to provide Windows 10 desktops for Azure, or at the very least, make it much simpler, which is also something that we'll look into in the next couple of slides. At the moment, we're actually left with another decision to make between the licensing models which are involved in the process of deploying either a remote desktop services solution or a PDI. With the remote desktop services, there are actually three licensing modes. The remote desktop for administration, which is a licensing mode that would allow for up to 2 administrative sessions, including a local console session, and allow you to run simultaneously on a Windows server. Now, this is the only licensing mode that would not require the remote desktop client access licenses or a licensed server, and it's actually intended to allow administrators to connect to a Windows server remotely in order to perform administrative tasks. Now, a server is in remote desktop for administration licensing mode if the remote desktop session host role service is not installed. Now, another licensing mode would be per user, which would require a remote desktop CAL for each unique user that will connect to a remote desktop session host, regardless of the number of devices which will be used to connect. And last would be the per device. Now, this licensing mode requires a remote desktop CAL for each unique device that will connect to a remote desktop session host server, regardless of the number of users that will connect from that device. Now, the appropriate licensing mode for a particular remote desktop session host server depends on multiple factors, such as the number of users and unique devices that will establish a remote desktop session to that server. And in the process of purchasing cows, they must be uploaded to the licensing server. And if appropriate, the remote desktop session cow is available from a licensing server. The remote desktop session cow is used for that particular client. Now, the per user and per device licensing modes require a server environment configured with the remote desktop licensing role service without any remote desktop cows applied to that server. So if you're planning to repurpose some of the existing Windows Server licensing, which you have on hand, let's take a look at the next slide. Now, since RDS is tied to a Windows Server version, the RDS version of Windows Server 2008, believe it or not, some people still use it, or 2016, are actually hardwired into each platform and are pretty different from each other in terms of functionality and performance. Now comes the tricky part. The cows you bought from Windows Server 2012 deployment will not be accepted on a Windows Server 2016 platform if you don't buy software assurance. However, the 2016 RDS cows is downwards compatible with RDS of 2012. For example, when you make an attempt to license a Windows Server 2016, with all the previous versions of RDS and including Windows Server 2012, you can only host licenses up to Windows 2012. Now, however, upwards compatibility is quite obviously possible with software assurance, which must be previously purchased with RDS CAL licenses. Now, in that case, you just upgrade the last available version. If not, to the new RDS CAL is needed to be purchased. And Since we've licensed of our ephemeral deployment, let's look into the existing infrastructure and make sure that the blueprints match. Now, don't get me wrong, everyone's having thoughts of better days of a hybrid cloud deployment, but it's really worth it, especially when calculating all the investments made into your existing infrastructure that would, in essence, include proactive support, results in multiplying the additionally required investment into the cloud by 2. Now, with that said, let's look into what it has to give. Now, even though a best practice would indicate having at least a minimum amount of storage redundancy, it's recently become even more difficult to play safe. Now, given that the deployment of an HCI, just like the implementation of an SDS, is just a phone call away, the installation of the previously mentioned services is only a modification that would need to be made in the department of RDS or VDI. Now, for the purpose of providing your users with maximum remote desktop accessibility, another undoubtable requirement would be having an automated backup scenario in place. That would include not only storing your backups on a separate hardware appliance, but having the process of offloading your backups to the cloud completely automated. Now, by storing your backups in the cloud, you can not only improve their recovery time objective, but jump the distance between data centers when a restore to a DR comes into play. Now, all these aspects put the missing pieces to the puzzle, but they're lacking just a single one: the possibility of migrating the costs required for having a constantly running infrastructure in the cloud. Now, the process involved in providing unified access to your cloud infrastructure has never been easier. There are many analytical tools that can be used for gathering and analysis of the resource utilization, allowing your users to require just as much resources as the previous experience when accessing their virtual remote desktop in the cloud. So let's take a look at the bells and whistles of a cloud RDS deployment. So for starters, RDS is not what it used to be. In Asia, it is now called Windows Virtual Desktops, and Windows Virtual Desktops is what now offers multi-session Windows 10 VDI in Asia, where the RDP components of the infrastructure are run as a product as a service and are managed by Microsoft. The Windows Virtual Desktop is used to access remote desktop service-based applications and desktops, but I'll leave out the remote desktop services part, since Windows Virtual Desktops doesn't bring a lot of benefits for remote desktop service-based environments. What is the difference, you may ask yourself, right? But the two big differences between VDI and RDS really comes down to reducing cost and how you acquire your Windows 10 license. Now, with Azure, your runtime cost includes the Windows Server license and user CALs. Um, all you need to do is just add additional RDS CALs for each remote desktop service user. The same cannot be said for Windows 10 licenses, where Microsoft would be releasing new Windows 10 licensing mechanisms, but not have seen a couple of solutions for running Windows 10 in Azure in a VDI environment. Now, for a technical perspective, Windows 10 client operating systems are managed by the Windows Server infrastructure and require the ability to be able of creating a new virtual machine on demand. Now, for every VDI scenario I've seen, that means a Windows Server infrastructure will require access to the hypervisor host. Azure does not expose the hypervisor host to external management, so the only way I can see running VDI in Azure is with nested virtualization. That will mean that whether you have 1 or 100 users connected, you must always have an Azure nested virtual infrastructure that can support all of the 100 users running at the same time. Now, to me, this limits your ability to manage runtime costs if you're using VDI. Now, when you want to migrate your virtual desktop to Windows Virtual Desktops, there are actually a few things to consider. Now, the first will be suitability of a migration analysis, where there could be an operating system constraint to Azure, and in other words, you'd need to understand whether on-premise operating systems are compatible with Azure's cloud services. Second one will be sizing of the CPU memory, and to understand the sizes of the vCPU ratio and memory, you would require shifting your on-premise CPU memory size to Azure before making a transition. Now, the third one will be license and dependencies, and to understand the license requirements and dependencies to ensure that you are not leaving anything behind. The collection of users would be required for pool desktops and others needing standalone desktops. Now, an additional one would be application rationalism, where you need the applications to be rarely used or at least analyzing all of the applications used previously before making that migration. And the last one would be cost estimation, most probably the most important one, which would help you know the cost of moving your desktop resources to Azure and running them. Now, the process of migration itself can be divided into two paths. Now, the first path would be focused at the operational efficiency, which would help you lift and shift your desktop environment to Azure and modernize them later. Now, the trigger here is infrastructure-oriented data center lease, expiry, and etc. Now, the second path would be focused on innovation and efficiency. So the triggers are mostly app-oriented, like legacy apps, and if you wish to modernize them, you'll be gratified with a category of building everything ground up. You can use this path. Now, the journey would include setting up your virtual network connected to on-prem, so the setup of actual directory, the synchronization of the Azure Active Directory and the on-prem directory, the creation of objects for Windows virtual desktops and generation of registration tokens. And one thing to keep in mind would be that Windows Virtual Desktop does not support user profile disks, which you are currently using right now in your VDI environments, for example. Now, another Azure service which might be of your interest would be auto scaling groups, which would allow you to automatically scale the groups of previously created VDI deployments. Another feature would be the automatic start and stop of VMs from that Azure marketplace to quite obviously allow you to automate the process of starting or stopping VMs during off hours or in a case of an increase of utilization. Auto shutdown would also be possible, and at this time you don't have any choice when it comes to region, at least not regarding Windows virtual desktops where you do remote desktop services, of course, but when the Windows virtual desktop goes live, keeping latency in mind, you might want to have to take a look at the different regions, price-wise, I mean. But moderately priced Azure VM, we have found that one instance of Windows Server 2016 can usually support 4 to 8 simultaneous users. Now, this means that one single Windows Server license and one single Azure virtual machine can now support your 4 users at a lower cost than Windows 10. Of course, you can make the virtual machine larger to support additional users, but we do not want to advocate continuing to make the VM larger. That can increase the expenses quickly. At the end of the day, the cost involved in the deployment of such a solution will either break or make the project, and an Azure VM runtime cost of running the 4 VMs required to support 4 users with Windows 10 compared to a single VM running with the Windows Server operating system, but we'd prefer having multiple VMs, each one supporting between 4 and 8 users replicated between availability zones and bundled with the possibility to create a disaster recovery site whenever it may be needed. Now, there are other solutions on the market which would provide you with similar flexibility and functionalities, just like Windows RDS or VDI, either on-prem or hybrid environments on the cloud. And those solutions would include the synergy of Citrix Xen Desktop with Windows or VMware Horizon View. Now, each one of them are fundamentally different in between their architecture and the licensing which would be required as far as implementation within your existing environment. So that's about it, and Thank you for joining today's webinar. Just wanted to find out if you have any questions. Feel free to have them addressed within the chat. Great. So we've got a first question from Vu Ha, and he's inquiring as to the methods used for connecting an on-premise environment to an Azure infrastructure. And yeah, there are actually several methods. They all range in between the costs involved and the bandwidth of uploaded or downloaded traffic from the cloud or from the on-prem, and would include Azure Connect or the creation of a virtual WAN in between the on-prem and cloud sites. But once again, due to the performance requirements and the network constraints, followed by the redundancy involved, the implementation of each method would not be so cost efficient. If, let's say, for example, you are running a highly performing environment where there's actually an SQL database involved, um, it wouldn't really possess a benefit. But for providing user client access to the remote desktop server infrastructure from the cloud, I think they would be completely suitable as long as you're willing to pay the price. Yeah, another great question from Gerard, and he was inquiring as to the possibilities of failover from an on-prem to the cloud in a hybrid scenario. Yeah, that would once again be possible, but once again limited by the throughput and the bandwidth of your connection to the cloud. And it would even be possible for you to fail over across different VMs as far as the user connection would go. But um, in regards to failing over VMs from on-prem to the cloud, that is actually something that is not quite ripe at the moment, I would say, and would take a lot of time to replicate the data in between the sites, and let alone then restore the VM after it's been failed over. Okay, everyone, so thank you for attending today's webinar. I guess we can call it a wrap. Once again, feel free to address any of your questions related to the topic or any other topics which you may be interested in to our sales department, and we'll be more than happy to research the possibility of having them on air.